we're going to be going over oxidation numbers. So I have the slides open. I would suggest having the periodic table, the assignment, and the slides open as you do this. We'll get to the actual assignment. That'll be the last thing we get to. So oxidation number, what this represents is the electrons that an atom has to gain or lose to get back to its neutral state. So basically, what's going to happen, the atom enters a bond, it's going to gain or lose electrons in order to participate in the bond. And what the oxidation number does is it tells you how many electrons it would have to lose or gain to get back to that state. It oftentimes ends up being the same as the charge due to the fact that, say, if you gain 2 electrons, you have a -2 charge. That also means you need to lose 2 electrons to get back to normal. So oxidation numbers typically is the same as the charge. So here's the rules. I might suggest writing these down as we go through them. I think it would be very helpful just to have the piece of paper with these rules down. I'm not going to keep going back to the slide on the rules. I'll go through them once, and then I will just bring them up, but I'm not going to go back through this slide. So look, the first rule, if it's in the natural form, the oxidation number is 0. What that means, if you just have some random element by itself, so you have just a plain carbon, its oxidation number is 0. Right? You have a plain argon, oxidation number is 0. So if you have a plain element by itself, oxidation number is 0. If the element is charged, then the oxidation number is equal to the charge. So if you have some carbon, but it's C plus 2, oxidation number is now plus 2. If it's C minus 1, oxidation number is minus 1. So if the element is by itself and charged, your oxidation number is just whatever the charge is. Now, if we have a compound, so we have a bunch of stuff bonded together, then what you'll do, everything in it has to add up to 0. So if you have something that's -2 and it's bonded to one other element, well, then the other element has to be plus 2 to balance it out. So they always balance each other out. The exception to that, when I say they always balance each other out, will be right here where it says if you have a charge, then your oxidation number is equal to the charge. So a rule that we have, if you have a compound and the compound is charged, then your final oxidation number has to equal that charge. We'll get more into that later. Rule number 4 is the most important part. So what happens, some elements you're going to figure out the oxidation number just by doing the math, by seeing what it takes to balance out the rest of them. But there's certain ones that have priority and typically get the number that they want. So group 1, for the examples we're going to do, always will be plus 1. So that's all you want to look at the periodic table, see where they're at. Everything in this first column, they're always going to be plus 1. Okay, group 2 is always going to be plus 2. That's all these guys right here below BE, always plus 2. And then hydrogen is plus 1 when bonded to nonmetals, but it switches to -1 if it's bonded to metals. Oxygen is always -2. There are some exceptions, actually. When it bonds to itself, it can change. When it bonds to fluorine. But for the examples we're doing, we're just always going to consider oxygen to be -2. And then last but not least, the halogens, group 17. Everything here in group 17 is -1. So to recap, group 1 plus 1, group 2 plus 2. Oxygen is -2. Halogens are -1. Now you might be thinking, what about the other ones? The other ones, they can change. So we're going to figure out what their oxidation number is based on what they're bonded to. As we go through these, if one rule contradicts another, the rule that we listed first is what's going to be followed. So let's do these. What's the oxidation number? First we'll do for Na2O. So the compound is Na2O. And what you'll be doing for these is you'll be figuring out what is the oxidation number of the Na, what is the oxidation number of the oxygen. So in order to do this, let's see, are any of these in that category for rule 4? So are any of them in either group? Let me move this. Are either of them in group 1, which is always plus 1, 2 is always plus 2, oxygen is always -2, and then group 17 is always -1. So let's look for N. Is N in any of those groups where we know what's going to happen? Yeah, it's in the group 1. So no matter what happens, we know that N is going to be plus 1. Now we can either do the math to figure out what O is supposed to be, or it might work out where O is also one of the predictable ones. And remember, the predictable ones are group 1, group 2, oxygen in group 17. So oxygen, that's O. So we know that. And remember, the rule was that O is always going to be -2. So if we look right here, O is -2. And with this one, this is easy. We don't have to do any math. We can just figure out what it is just based on where they're at in the periodic table. Now, it happens to work out. We have 2 of the NAs, and each of them is +1. So what happens if you have +1, but you do it twice? It's now +2. And then we have a -2. They balance each other out, right? This is like you have 2 +1s and 1 -2. They obviously balance out. So it works out where the math adds up, but we didn't even have to bother doing the math because it was 2 elements that we could figure out what they were just based on where they are on the periodic table. So what about H2SO4? This is going to be a harder example. There's a lot going on here. So let's do H2SO4. So we need to find H, we need to find S, we need to find O. You know what I'm going to do? I want to leave some room to do a little bit of math, so I'll write these more to the side. So we need to find H, we need to find S, we need to find O. Okay, so let's look at where they are on the periodic table. So we have H. Right here, it's group 1. So H gets to be +1. Okay, is S predictable? S is in group, whoops, let me open this back up. S is right here in group 16. Now, yes, oxygen is -2, but the other ones can change. So let's leave S blank. We don't know what S needs to be yet. Leave it blank. And then oxygen, we know that oxygen is always -2. That's one of the ones that we know for sure. So look at what the situation is. You have 4 of the oxygens, 2 of the hydrogens. We know what hydrogen, we know what oxygen are. We need to figure out what sulfur needs to be. And remember the rule that says they all have to add up to 0. They have to balance out. So hydrogen is +1. And how many hydrogens do you have? Well, you have 2 of them. So all the hydrogens add up to +2. Oxygen is -2, but how many oxygens do we have? We have 4. So all the oxygens add up to -8. Now, what is S? S, somehow, what needs to happen, all of these need to add up to 0. So we have +2, we have -8. What else do you need in order for this to end up at 0? You need +6, right? Because 2 + 6 makes 8, -8 balances out to 0. So sulfur had to be +6. How many sulfurs are there? There's only 1 sulfur. So that single sulfur had to have a +6 charge. So the sulfur right here has a charge of +6. So that's what we do. Sometimes you have to do the math, sometimes you don't. So what we can do, actually, I'm just going to skip this. We did this in the last lesson. So, and then things like sulfur we did, nitrogen can have a bunch of different oxidation states. There's multiple elements that can have more than one oxidation state, depending what they're bonded to. So let me do this example. So what you'll see is that because nitrogen is not in the list of elements that are predictable, I'm going to do 4 examples in a row where you get a different number for nitrogen each time because nitrogen can change depending on what it's bonded to. So we'll do N2O5, we'll do NO2, we will do N2O, and then we will do NO. Okay, so let's look. So N2O5, here's what we know. We need to find N, we need to find O. We don't know what N is, it always changes, but we know that O is -2. All right, so if O is -2 normally, and there's 5 of them, what's -2 times 5? That's going to be -10. So then what does nitrogen have to be? There's 2 nitrogens. We need to have a +10 in order to balance out the -10, and there's only 2 nitrogens. So what does nitrogen have to be? It has to be +5. Because +5 times 2 is going to make the +10 to balance it out. So nitrogen in this case is +5. Let's do NO2. We don't know N, but we do know O. O is always -2. So O is -2. How many O's are there? There's 2 of them. Negative 2 times 2 is going to make negative 4. Nitrogen has to balance that out. So nitrogen has to be plus 4, and there's only one nitrogen, which makes it easy. So nitrogen here had to be plus 4. N2O. Once again, don't know nitrogen, but we always know oxygen. Oxygen is negative 2. So if oxygen is negative 2, there's only one of them, so just keep it at negative 2. And you need to have positive 2 to balance out the negative 2. However, there's 2 N's. So each N has to be plus 1, because plus 1 times 2 gives you that plus 2. So in this case, N is plus 1. And then here we have NO, just plain NO. It's actually the easiest out of all of them. We know that O is negative 2. So O is negative 2. There's only one of them. And so N has to balance out the negative 2 with a plus 2. And there's only one of the N's. So N has to be plus 2 to balance it out. Look at all the different answers you can have for N, depending on how many N's you have and how many O's it's bonding to. Okay, and then the last rule is that the oxidation number, if the polyatomic ion is charged, then the oxidation numbers, rather than adding up to 0, have to add up to that charge. So let's do 2 examples, and then I'll be done going over this. You can work on the assignment, and then what I'll do to keep this one from being too long, I'll have a second video attached on the assignment where I just go through what answers you should have gotten. I won't work all of them out, but I will go over what the answers should be, so you can double check yourself. Okay, NH4 plus. And then after that, we're going to do PO4 3 minus. Okay, so NH4 plus, we don't know N, we do know H. So, you know what, I need to go back and show you something in the slide. Remember with H, you expect H to be positive, it normally is, but just remember this exception with H. It's plus 1 when it's bonded to nonmetals and negative 1 when it's bonded to a metal. So hydrogen here is bonded to a nonmetal, which is hydrogen, or which is nitrogen. Nitrogen's a nonmetal. So we keep H positive. When all you have is H, it's worth it to double check to make sure you're doing it right. Typically, the examples we have, hydrogen is going to be plus 1. We're normally going to have it bonding with nonmetals. Okay, so back to this. So we know that hydrogen is plus 1. So if hydrogen is plus 1 and you have 4 hydrogens, that adds up to plus 4. Okay, here's what's weird this time. When these combine, they don't need to add up to 0 because it's NH4 plus. Remember, if you have just a plain plus, you can imagine there's an invisible 1 there. So it's plus 1. It's 1 plus. So we need to get it to a charge of positive 1. So now nitrogen, it doesn't need to be negative 4 because you don't want to balance that out. You want to have plus 1 left over. So nitrogen needs to be negative 3. And there's only one nitrogen, so that single nitrogen has a negative 3 oxidation number. So negative 3 is what we get. Okay, let's do PO4 3 minus. Again, this is going to end up equaling negative 3 because that's what the charge is. So what we have, we don't know P yet. We are working on O. O is negative 2. We always know that. So if O is negative 2 and you have 4 of them, negative 2 times 4 gives us negative 8. So negative 8, what number can go right here? So what number, when you do minus 8, has negative 3 left over? Well, that will be positive 5. And since there's only one P, that single P is happy as plus 5. So plus 5 is what we get for P. So that's how we do this math. That's the kind of things we need to go through to figure this out. That's how we'll do this. So make sure that you just take your time, go through each of the things, look back at the periodic table if you need to, work on these problems here. And then, like I said, I will do a video. I'm not going to go through every single one, but what I will do is just run through them and discuss what answer you should be getting. And then if you have any questions, please just email me. So again, there will be a video at the bottom of this where I will discuss what answers you should have gotten for this.